There we go. Okay, so the first question I got, they give you a formula and they tell you to plug and chug. Okay, I think this question, let's see if I got it written down. Yeah, it says gives you F is equal to 0.6 W, I'm sorry, W, depending on where you're from. If you're from around here, it's W. Sine of theta plus 90 over the sine of 12 degrees. And I think they tell you that W is equal to 165. And hold on, theta is equal to 45. And it's plug and chug. So A, they asked you this right here, plug and chug. So that's going to be 0.6 F is equal to 0.6 times 45. I'm sorry, 165. Sine of 45 plus 90 over the sine of 12 degrees. And of course, you put it in degree mode. And that's going to be 99 sine of 135 over sine of 12. And that comes out to be 337 pounds. So that basically means when your back, here's your legs, there's your feet. When your back is at a 45-degree angle and you're picking up something, and this is at 45 degrees, that basically means that you're exerting about 337 pounds of force on your back. Why can't you join the link today? Shaw, Andrew Shaw. Hold on. Shaw, Andrew. Okay, see if anybody else is missing. Let me know if Mr. Shaw gets in. It says it's calling him, so hopefully it'll answer. All right, B says, the B part. Says use identity to show that. Mr. Shaw, did you get in? I think he came in. He just muted his. F is equal to 2.9 W cosine of theta. And I can tell you right now that this, this original right here, this right here, that sine of A plus B, that looks like sine of A plus B. Sine of A plus B. I'm going to highlight that. So I'm going to write sine of A plus B. If I remember correctly, sine, cosine, cosine, sine, right? Sine, cosine, cosine, sine. Y'all check me. Look at your cheat sheet.
That's right.
We're going to use that right there. So you take your highlighter out. So I need y'all to plug and chug. You haven't done this problem. Go ahead and plug that into this. basically you're going to get theta 90, theta 90. So I'm going to rewrite it. So F is equal to 0.6 W. Oh gosh. Sine of theta cosine of 90 plus cosine of theta sine of 90 over sine of 12. So F is equal to 0.6 W sine of theta cosine of 90 degrees. Well, cosine of 90, I believe that's going to be 0, is it not?
Yes, sir.
Plus cosine of theta. Sine of 90 is going to be 1 all over the sine of 12. F is equal to 0.6 W. That goes out. Cosine theta over 12. Take your handy dandy calculator. I don't even know if I've used mine in so many classes, I don't know. 0.6 divided by sine of 12 degrees. Sine of 12 degrees. Where is second angle? Degrees. Close. Ah, horse pucky. Second quit. 0.6 divided by the sine of 12 second angle degrees. 2.88 or 2.9. I think that's what we needed, didn't we? 2.9 cosine of theta. Look at the directions. Yeah. And that's how you do that problem. See if it has a C. Now the C, they want you to graph this function and basically see what its max is. Okay, C, so you would graph that function. You could graph the first function, or you can graph the second function. It doesn't matter, 6W cosine. So if you graph y is equal to parentheses 6, wait a minute, 2.9 cosine theta. Clear. 2.9 cosine theta. And graph. And zoom trig. And trace it and find your max. If I can find trace, there's your max right there, 2.9 or right at 3. And your min is going to be 0. Realistically, it's going to be 0 because I don't think they're going to ask you for, what is this? This is force, right? Yeah. They're not going to ask you for, so at 90 degrees, if you're at 90 degrees with your back, wait a minute, hold on. Let me go backwards. Yeah. If you're at 0 degrees, if you turn and x is equal to 0, if you're, that means you're parallel with the x-axis. Okay, if you're parallel with the x-axis, then that's going to maximize the force on your back. And I guess that would be true because you're bending at 90 degrees. So that would be true. Not a test question, but it's a pretty good question for homework. It's too long to be a test question. I've got a couple of good test questions. In fact, here's one good test question, and I got 2 of them, so we're going to do both of them. I can't remember which one. Let's see. This is a test question that I would pull out of 10.3. Let me pull up the homework. Let's see if I can find it. There it is. See, I got 2 of these questions from 2 different people. So I'm going to do both of them. The first one is this one, 1/5. And make sure you mark these test questions because these are the kinds of questions I would ask you because it kind of uses a lot of your algebra background as well as your trig background. And that's what I like to put on a test. So, of course, the first thing you got to do is you got to find out where you are. Okay, so find out where you are. You're in quadrant 2, because it says right here, quadrant 2, right there. And then pull up, let's see if I can find it. No, that's not it. Where is my, I'm going to pull in y'all's identity files, trig identity. And you're going to use cosine 2x. Cosine of 2x, you can use any of these. I'm going to use 1 minus. Let's focus on 1 minus sine. Let's do that one. I mean, you can use whatever you want to, but I'm going to use that one. So the cosine of 2x is equal to 1/5 and pi over 2 x pi. That means that's quadrant 2. And basically the directions say, I guess, do the 3 trigonometric functions. And I'm going to use cosine of 2 theta is equal to 1 minus 2 sine squared theta. That's what I'm going to use. So I'm going to take my handy dandy orange highlighter and I'm going to use that identity. Now, what told me to use that identity? Well, that 2 right there. Oops, I'm sorry. That 2 right there kind of sent up a flag that said double angle. So I can actually put this in for that and get 1/5 is equal to 1 minus 2 sine theta squared theta. Now, can you solve this? Somebody say yes or no. Can you solve it?
Well, are you trying to solve for cosine or sine?
You're solving for sine. That's all that's there.
Then yeah,
That's
you can
it.
solve that.
Yes, you can. Algebraically, this is algebra right here. That's why I love these questions, because it basically reverts to your algebra skills with your trig skills. So now solve that. I'll give you 30 seconds to solve it. So, well, -1 here, -1 here. So 1/5 minus 1 is equal to -2 sine squared theta. And of course, we can't do this because this is a fraction, so we just might as well quit. 1/5 minus 5/5 is equal to -2 sine squared theta. And that's going to be -4/5 is equal to -2 sine squared theta. I'm going to write this on the next page. -4/5 is equal to -2 sine squared theta. Divide by -2. Divide by -2. Multiply by 1/2. And that's going to be 4 over what? 10, which is what?
2/5.
2/5. Take the square root of both sides. And that's going to be, let's see, sine theta is equal to square root of 2 over square root of 5. And then I'm going to multiply. I'm going to try to save some room, so I'm going to use a highlighter. And that's going to be the square root of 5 over the square root of 5. So the sine of theta is equal to the square root of 10 over 5. Now you're well on your way to finding the cosine. I think that's what we're finding, right? Yeah. So now take that, what I just finished there, and find the cosine. Now remember where you are. Half a trig is knowing where you are, what quadrant you're in. So I'm going to write this on the next page. Sine of theta is equal to the square root of 10 over 5. And our original directions want us to give we want the cosine of theta, and it's in quadrant 2. That's from the directions, quadrant 2. Well, heck, all we got to do is Oscar had draw a picture. square root of 10, 5, and this is going to be A. So A is equal to the square root of 25 squared minus the square root of 10 squared. I have no idea. 25 times 25 is 625, isn't it? Oh, I'm sorry. 5 squared. So A is equal to 25 minus 10. And that's going to give me A is equal to 15. I added the negative because you have to. And I'm going to highlight that negative
Quick
because
question.
that's part of the answer. Well, it won't, yeah, all students take calculus, the cosine will be negative. So cosine of theta is equal to, Oscar had a hunk, which is negative square root of 15 over 5. That's why I love those questions, because they're short and sweet and to the point. So this one is kind of like that one. Let's type it in. That's square root negative. I ain't gonna type all that. Well, negative square root of 15 arrow over divided by 5. All right, now I want y'all to do this one. Let's see, that was 1/5. This was just, somebody sent this one, and it was about the same as this one, so I'm gonna let y'all do it by yourself, and that way you can tell me the answer. Cosine of 2 theta is equal to 4/5, and 90 less than theta less than 180, which means quadrant 2. Okay, so let's do that one. Let y'all do it. I'll give you 2 minutes.
What are we trying to find?
You're finding cosine.
Okay, thank you.
Yeah. You're finding just cosine of theta. Just like the last problem.
Gmail.
Well, I should have checked right before class on how many states are rescinding their election predictions because their votes are off. Y'all notice that? About 3 or 4 states have said, uh-oh, something's wrong with our votes. Mail-in voting was a joke. They should never try that again. Too many dishonest people.
Priority 1 message coming in on secured channel.
Good gosh.
Priority.
Okay, that's 2 minutes.
I got -3 root 10 over 10.
Let's see what I got. I got -3 root of 10 over 10. Is that what you got?
Yes, sir.
Good job. So there's 2 test questions right there you could get. The solution that I got was -3 square root of 10 over 10. And that's equal to the cosine of theta. Actually, you get -3 over the square root of 10, and you have to rationalize the denominator. So there's 2 questions, well, 3 questions. 1 not so good test question, but 2 good test questions. Let's see what this one, I think this is the book question. This one's got like 15 parts. I can't remember. Let me see if I can find this one. Or one like it. I think we already did that one. 10-3, 10-3, 3, 13. I bet it's this one. Oh. Okay, 10-3-13. Well, this is one like it. I don't think it's the same as the one I'm fixing to do. It's one like it because 2 or 3 people sent it. Well, it ever comes up. Okay. Says use ID, use identities to find sine of 2 theta and cosine of 2 theta. The heck with it. Okay, use ID, use identities to find the sine of theta and the cosine of theta given the tangent of theta is equal to 5 and the cosine of theta is greater than 0 or positive. The cosine of theta is positive. Well, all students take calculus. Where is the cosine positive?
Quadrant 4.
The first and the what? And where is the tangent positive?
First and third.
Well, here, because we got this is not highlighted. So chances are your answer is going to depend somewhere on the first quadrant. All right, so what do you do first? Well, the first thing you do is I would use the tangent squared plus 1 is equal to the secant squared because you're given tangent. All right, I'm going to write this down in red. I'm going to write it in red. That means you need to write it in, it's very important. Since you're given tan, you might want to start with tan. Tan squared plus 1 is equal to secant squared. Or secant squared theta is equal to tangent squared theta plus 1, because you're given tangent. So with that, that's going to equal 5 squared plus 1, which is equal to 26, which is equal to secant squared. And secant is also 1 over cosine. So since 1 over cosine is equal to the secant squared, and secant squared is equal to 26, I can set these two equal to each other. And that's going to give me 1 over cosine squared is equal to multiplied by cosine squared. 1 is equal to 26 cosine squared divided by 26. So cosine squared is equal to 1 over 26. Now, if you remember correctly, I'm going to just circle that for right now. Remember, the cosine of 2a is equal to 2 cosine squared a minus 1. Well, you've got cosine square a right here. So that's going to equal 2 times 1 over 26 minus 1. And that's going to be 1 over 13 minus 13 over 13, which is equal to negative 12 over 13. And that's cosine of 2 theta. And that's part B. So in this question, you get part B before you get part A. Therefore, part A is going to be equal to tangent of 2a is equal to 2 tan of a over 1 minus tan squared of a. Now I can just plug and chug because I've got tan. Okay, remember tan is equal to 5. And just plug and chug. And if you got the tan, you can change it to the sine over the cosine. So tan of 5 is going to be 2 times 5 over 1 minus 5 squared. And that's going to be what? 2 times 5 is 10. So that's going to be 10 over 1 minus 25. What, 24? I'm looking. 1 minus 25 is 24. And that's equal to 5 over 12. I'm going to go to the next page. So the tan of 2 alpha, or 2a, is equal to negative 5/12. Okay. We know that the tan of 2x is equal to 2 tan, wait a minute, sine of 2x over cosine of 2x. And we've got the tan of 2x, that's negative 5/12. And cosine is negative 12 over 13. Multiply both sides by negative 13/12. Sine of 2x is equal to, wait a minute. Yeah, I was going to see if it, I thought that it would cancel. It doesn't cancel. Hold on a second, I'm looking. That's not going to cancel. I thought it was going to cancel.
The 12 should cancel.
Yeah, why isn't it canceling? If I divide, multiply by 13 over 12, 13's the 5's that's supposed to cancel.
Are you multiplying or dividing? Like with that negative 13 over 12?
I should be multiplying by 12 over 13.
Yeah, so that's what you did wrong.
That's it, 12 over 13. I did the reciprocal. 12 over 13, there we go. The 12s cancel, and that leaves you with 5 over 13. That should be your answer. Now, why I do appreciate this question, I probably would not put this on a test because it's a little bit too long for one problem. But it's not too bad for 2 problems. But I don't think they have a question in the homework. It's just one of these. So this question, you actually found B first. You found the cosine of 2a is equal to negative 12 over 13. And then you use the tangent. Since you were given tangent, that's why you're using the tangent. A lot of people, when they start this problem, they see tangent, and then they say, you know, what are we supposed to do? The question asks to say, what's the question say? I can't remember what the question says. hold on a second. It says find the cosine, and immediately people think, okay, well, cosine is 1 over the sine or whatever. In other words, they don't think about what you're given. And you're given tan is equal to 5. I can't find the original problem. I've got it somewhere here. The tan is equal to, here it is. The tan is equal to 5. You got to remember that if you're given something, you've got to figure out a way to use that identity to plug something in for it. And tan is 5, therefore tan squared is 25. So that helps you out with that one. So homework question, not necessarily a test question on that one. This one is a test question. And we did this one the other day. This is 10.3. And people are sending questions in, and we went over them last week, but that's okay because this is identities, and I know identities suck. 10.3, 25/6. I don't know if this is the one that I printed out. Let me see if the numbers match. Yeah. And we did one like this, so write this down as a test question. First thing you're going to do is you want to factor because you want it to look like 1 minus 2 sine squared of alpha or theta. You want it to look like that. Because cosine of 2 alpha is equal to that. So you see you got a sine. So that sine squared is a good indicator. So I'm going to rewrite this. 1/4 minus 1/2 sine squared 45.8 degrees. And I'm going to highlight just in yellow so you'll notice it. You see this minus, and you see this sine squared and theta. And when you see that minus sine squared, that ought to kind of tell you, not Pythagorean, because you got a negative out here. You're thinking 1 minus 2 sine squared. Because when you factor out that 1/4, you basically are doing 1/4 divided by 1/4 minus 1/2 divided by 1/4 sine squared 45.8. And of course, that's going to be 1 minus, multiply by 4 over 1. That gives you a 2. And there is your identity. So I'm going to take my pink highlighter. And we know that this will give us this. And A is equal to 45.8. So with that information, we can say 1/4 this is equal to that, but alpha is 45.8. 2 would be 91.6. And that's your answer. Again, I like it because it's short and sweet. So 1/4 cosine 91.6. $91.6. Yep. Next one. 10.335.8. 10.335.8. Again, I don't know if this is the one, there's several that sent it. Okay, this is not the one, so I'll just do this one and we'll just use there's the directions. Use the half angle identity to find an expression for the exact value of the function. Okay, so I'm not gonna do this one. I'm gonna do the one that I've already picked out. So here's the one that I have. Sine of 5 pi over 12. And they want you to use half number identity, half number or half angle, whichever one you want to call it. To find the sine of 5 pi over 12. So cover that up. We're just using 5 pi over 12. Now I'm going to try to do this in a kind of a methodology or methodical type deal because this one can be a pain. It's not a long pain, but it's a short pain. The first thing you want to do is take that 5 pi over 12 and multiply it by 2 because it does say use the half angle identity. So half angle means that you got to divide or multiply by 2 depending on which way you're going. So on this one, first thing you want to do in pink, multiply theta by 2. Okay, when you do that, you actually get the number that you divide in half to get this number right here. Okay, so I'm going to multiply 5 pi over 12 times 2. And that's going to give me 5 pi over 6. So 5 pi over 12 is half of 5 pi over 6. It's kind of important that you realize that. We also know, that 5 pi over 12 is 75 degrees, which is in quadrant 1. So far, I haven't done anything different. The only thing I did was I multiplied theta by 2, and that gave me the angle that we divide in half to get this, okay? Because 5 pi over 12 is half of this angle right here. Now, if A is equal to 5 pi over 6, because that's what we got right here. So A over 2 is equal to 5 pi over 12. Half of A is equal to 5 pi over 12. We've already established that right here. So this looks like sine of A over 2 is equal to positive or negative square root 1 minus cosine of A over 2. Now we've established that A is 5 pi over 6. Take my green marker. So that can go in right there. We also know that it's going to be positive because we're in quadrant 1. So 1 minus cosine of 5 pi over 6 over 2. Now, for those of you that don't know, 45 degrees or 75 degrees, we know that. It's going to be the square root of 3 over 2. So we'll go to the next page. So that's going to give me the square root of 1 minus negative square root of 3 halves over 2. Now, I'm going to do something here to try to make things easier because of that radical. So what I'm going to do is I'm going to multiply. You don't have to do this, but it's something that might save you a little bit of confusion. I'm going to multiply, and you can change that to a plus if you want to. Let's go ahead and change that to a plus. I'm going to multiply the top and the bottom by 2. Well, Hubert, I wanted to multiply the top by 1 over 2. Well, you can do that, but I have found out they're doing it both ways. That's a little bit more complicated. So that's going to give me the square root of 2 plus the square root of 3 over 4. What that does is it gets rid of the fraction that you had out there. And then put the square root over everything. And basically you're going to get the square root of 2 plus the square root of 3 over 2. And that's sine of A over 2. Kind of long and drawn out for a test, but let's see what else we got. I got 3 or 4 more, so hopefully these will be short and sweet. I know 1 or 2 of them are. This is a test question. It's short and sweet, and we've already covered this, but I'm covering it again. 10.3, 4311. 10.3, 4311. Let's see if this is the same one. I think it is. No, it's not. Sorry, it's not the same one, but it's the same method. This one says, and I think we've done this one before. It's the same question, but just different numbers. Oops, sorry. I can't get anything to work. It's in Russians. Tangent of x over 2 given the sine of x is equal to 9 over 41 and pi over 2 x pi, which means that's in quadrant 2. So we're going to be using tan of x over 2 is equal to the sine of x over 1 plus cosine of x. Now I want you to take a minute and find out where you are given in quadrant 2 the sine of x is equal to 9 over 41. Take a minute and find out where you are. So we know we're in quadrant 2. And we know that sine Oscar had 9 and 41. So therefore, A is equal to the square root of 41 squared minus 9 squared. And I'm going to just put 3 dots because I did the calculations. A is equal to 40. And it's going to be a negative 40. Now all you got to do is find the sine and the cosine. You already got the sine. So now you got to find the cosine. So therefore, the cosine is equal to, Oscar had a hunk, negative 40 over 41. Now take these two, I'm going to highlight these blue. And plug in right there. So that's going to be 9 over 41 over 1 plus, it's going to be 1 minus 40 over 41. And 3 dots. 9 over 41 divided by 1 over 41. Dot, dot, dot. I got 9. Now that one could be a test question because it's pretty straightforward. Once you have the double angle right here, once you have it established, you know what you can look for. And remember, trig is easy once you figure out where you are. And when you find out where you are, that's when you do the Pythagorean theorem and you get basically this. Find out where you are. Second quadrant, and what is my net sine and cosine. Okay, this next one. This one isn't too bad, but it's not. This one is 10.34512. 10.34512. What time is class over? Oh my goodness, we're already out of time. All right, I'll go ahead and start this one for you. Okay. I think I've got this one written down. No, it's a little bit different. So I'll write it right here. Find the exact value of the function given that tan beta over 2 given tan of beta is equal to negative 11 square root over 5, and it's in quadrant 2. I'll just write it out. Pi over 2 less than beta less than pi, which means quadrant 2. And you're going to use anything with tangent in it, so that's going to be tangent of beta over 2 is equal to positive or negative square root of 1 minus cosine beta over 1 plus cosine beta. So kind of all this is preliminary. Now, since pi over 2 is less than beta is less than pi, and that comes from right here. Then if I divide every one of these divided by 2, and I get beta over 2, which is this right here. So pi pi over, let's say 2, that's going to be multiplied, divided by 2 over 1, pi over 4. 2 be beta over 2. Less than pi over 2. And that is in the first quadrant. Okay, this is in the first quadrant. I think that's 45 degrees and 90 degrees. So I'm going to put now that we know where we are, we know that the angle that we're given up here is in quadrant 2. So we're going to go ahead and do that. And we know that we've got negative square root of 11 over 5, and it's in quadrant 2. So that's going to be, well, we've got to have the negative to be 5, because the square root of 11's got to be positive. So C is equal to the square root of 11 square root of 11 squared minus negative 5 squared. And that's going to come out to be 11 plus 25. And that comes out to be 36. Now, once you got that, once you found out where you are, let's see. Since we're using this right here, we need cosine. So since we are using this identity right here, we got to find the cosine. I'll write it on the next page. So I'm going to leave that as part 2. And I'm going to go up here. Let's see, was that part 2? Yeah, part 2. Part 3. We're going to have tangent of beta over 2 is equal to positive or negative square root of 1 minus cosine over 1 plus the cosine. And that's basically going to be 1 minus, I'm going to go ahead and write it down for you, 1 minus negative 5/6 over 1 plus a negative 5/6. And you whittle it down, whittle it down, whittle it down, and you get the square root of 11. And that's going to be your answer. So we got to stop there. I've got all but 2 questions, and I'll cover those. I got 3 questions, no, 2. So I don't know. Somebody count up how many questions we do today. 7, 8.
Yes, sir. 8.
How much?
8.
8. Well, I've got 2 more. I've got 10.3, 59, 15, which is a test question. And then I've got, and I'll leave that right here for you. you want to copy the first part down. The directions is verify. So that's short and sweet. That's a test question right there. And the other one is a book. It's at least 4 pages long. So I'll wait to do that Thursday. The test is up. The homework has got a deadline on it. So you can go ahead and look at it if you want to. You'll also see that I gave y'all 5 attempts on the test. Now, why would I do that? Why would I give y'all 5 attempts on the test? Okay, nobody's going to say. Okay.
So that way we can't say that you didn't give us enough time to.
Well,
get it
yeah,
right.
I've given y'all plenty of chances, but why would I do that on this test? Why didn't I do it on the previous test? Why am I doing it on this test?
Because it's going to be a little bit tough.
Yeah, that's right. And plus, identities are important, so I'm giving y'all extra 2 times to work on it. You're welcome. All right, so let me go ahead and look at the roll right quick and shut this down and shut the recording down. And